In Lesson 3-3, we will discuss properties of logarithms. In video 3.3.1, our learning target will be for students to apply properties of logarithms. There are three main properties of logarithms that we will discuss: the product property, the quotient property, and the power property. If b, x, and y are positive real numbers and b is not equal to 1, right, our base cannot be equal to 1, and p is a real number, then the following statements are true. The product property states that if you have a logarithm and your input is the product of two values or two expressions, then you can separate those logarithms by adding two separate logarithms together. So log base b of x times y is equal to log base b of x plus log base b of y. The quotient property states that if you are taking the quotient of two numbers, so you have the logarithm base b of the quotient of x and y, then you can separate those logarithms by subtracting them. So log base b of x minus log base b of y is equal to log base b of x divided by y. Our power property states that if we have a logarithm base b of some input raised to a power of p, so we have log base b of x to the p power, you can then take that exponent and bring it out in front of the logarithm and multiply the logarithm by whatever your exponent p is. That is called the power property. Now, the same thing can be said for each of these properties. These properties can be used to condense or combine logarithms. So, for instance, if I had two logarithms with the same base, so if I had log base b of x and log base b of y, I can combine those two logarithms by multiplying x and y. Same thing said here. When I have the difference of two logarithms, as long as they have the same base, they can be combined as log base b of x divided by y. And then for the power property, if I have a number that I'm multiplying out in front of a logarithm, that number can be rewritten as the power of whatever input is of our logarithm. So we could say that p times log base b of x is the same as log base b of x to the p power. So basically what I'm saying here is that both of these, or all three of these properties, work in both directions. We can use them to expand logarithms, make them bigger, or to condense logarithms and rewrite an expression or an equation in terms of a single logarithm, where you only have one log rather than two, or 3 or 4 or 5 in some cases. So these are the three main properties of condensing or expanding logarithms, and it can make your life really a lot easier knowing these three properties when you're solving logarithmic equations. One thing I should mention that they don't mention here in this slide is that these properties of logarithms are also true for natural logarithms. So if I saw natural log of xy, that's the same as saying natural log of x plus natural log of y. And I don't need a base here because natural logarithms are always base e. So if you want to write in the little base e here, you can. But you don't have to. It's assumed that when you see a natural log, or ln, that it is always base e. So that's what the product property would look like using natural logs. Our quotient property would look like this. Natural log of x divided by y is natural log of x minus natural log of y. And the power property would be natural log of x to the p power is equal to p times ln of x. In example 1, we're going to use the properties of logarithms to express log of 96 in terms of log of 2 and log of 3. Now, what they're basically saying is that we can expand this logarithm to be in terms of still in base 10, but we're going to use log 2 and log 3 to rewrite or expand this expression. Now, what they're doing here is they're saying log of 96, right, 96, is equal to log of 2 to the 5th times 3. Now, how did they come up with 2 to the 5th times 3? Because they told us we were going to rewrite this expression in terms of log of 2 and log of 3. And 2 to the 5th power times 3 gives us 96. So all we're doing is rewriting 96 as 2 to the 5th power times 3. Now, from there, this logarithm right here, since I'm multiplying my inputs, we can use the product property to separate these two factors into their own logarithms. Each of these two factors can have their own log, and that's what they're doing right here in this next step. If you're multiplying two inputs together, then the logarithms need to be added together. So we have log base 10 of 2 to the 5th plus log base 10 of 3. That's applying the product property. And then in the next step, we can apply the power property, because that power property says that if you're taking the logarithm of a number that is raised to an exponent, which our exponent is 5, that 5 can be rewritten out in front of the logarithm and multiplied out in front. So we say log 5 times log of 2 is the same thing as log of 2 to the 5th plus log of 3. Okay, so in this step, going from step 2 to step 3, all we're doing is moving that exponent down out in front and multiplying by that exponent 5, and that's applying the power property. So our answer, once we've expressed log of 96 in terms of log 2 and log 3, is 5 times log of 2 plus log of 3. And I like to put parentheses around my inputs there. In example 1, part B, we're using the properties of logarithms that we discussed previously, the product, quotient, and power property. In this example, we're asked to express log of 32 divided by 9 in terms of log 2 and log 3. So somehow, I have to rewrite 32 either in base 2 or base 3, and same thing with 9. Well, I know that 32, the number 32, can be rewritten in base 2. And when I say base 2, 32 is the same as 2 to the 5th power. And the number 9 can be rewritten in base 3 as 3 squared. Okay, so really what I have here, when I say log of 32 divided by 9, that's really the equivalent of log of 2 to the 5th over 3 squared. Now, what I'm going to do from here is I'm going to apply those properties of logarithms. Now, I see that I have a quotient here with my input. So when I separate this quotient into separate logarithms, we are going to subtract them. So I could say log of 2 to the 5th minus log of 3 squared. Quotient means to take the difference of the logarithms. And then from there, I'm going to apply the power property by bringing each of my exponents down out in front. The power property says that if you're taking the logarithm of a number raised to an exponent, that exponent can be brought down out in front and multiply the logarithm by that value. So this should be written, log of 2 to the 5th is the same thing as saying 5 times log of 2 minus, we still keep this subtraction sign there, we're going to get 2 times log of 3. And this will be my final answer. We have rewritten log of 32/9 in terms of log of 2, right? We have a log of 2 here, and we also have a log of 3. And that is our final answer. In example 1 guided practice, we're asked to express the natural log of 125 divided by 27 in terms of natural log of 3 and natural log of 5. One thing I should state or remind you of is that the properties of logarithms, the product property, the quotient property, and the power property are true of log logs and of natural logarithms as well. So those properties that we discussed on the very first slide are applied to or valid for natural logarithms as well. So what I would like you to do is go ahead and figure out how to express natural log of 125 over 27 in terms of natural log of 3 and natural log of 5, and then submit your answer A, B, C, or D.